So let's get into it. No time to waste. Let's do it. We talked about objects, classes, references, references to objects that are on the heap, and how that works in memory, talking about heap space. We learned all the concepts, all the topics that we want to talk about on Monday and Wednesday. So today I want to give you a more complex example and just hammer down all the concepts through this example. So it gets pretty complex. The previous lecture had a good lot of questions during lecture as well. So any questions that you have as we're going through this example, please let me know. There's not strictly new content. There's some combinations of multiple different things that we've already learned. This is for your benefit to make sure you understand objects on the heap and references. So if you have questions, please let me know, because things will get a little bit intense when we get to this big spooky line right here. There's a lot going on there. So if you don't know the basics of what we're doing before we get to that line, it's going to get pretty tough. So please ask questions if you got them. Let's go through memory diagram. Okay, memory diagram starts off simple enough. We've seen this not a billion times, but since our very first memory diagram. Execution starts with the main method. We're going to slap two variables on the stack. And then we're going to get to the first new thing. The variables on the stack, I don't think I have to mention those ones anymore. But we get to our first new thing. Whenever we see literal new, whenever we see the keyword new, we know that we're creating a new object on the heap. So whenever I see that keyword new, I know I'm creating an object on the heap, and whatever follows is going to be a constructor call. So I'm creating a new party character. I'm going to call that constructor. So I need two very important things. I'm going to draw that new object on the heap. I'm going to put the name of the type of that object. And then I'm going to put space for the state variables of that object, separated by a line. So I have name and value for every state variable. And then a reference. This is a number that I just make up. We always have this OX, meaning that this is a hex value. Memory addresses are hex values. And then some number. When I made this slide, I decided 282 sounded nice. So I put 282 down. Usually I just whack my keyboard, whack the numbers on my keyboard. And if I don't like the number, I'll modify it a little bit or something like that. It doesn't matter. However you want to make these up on your quizzes, just make up any number. Some students just start with OX1, OX2, OX3 for each object that they create. It's perfectly fine, as long as it's a number. For whatever reason, I don't know, maybe it's the way my brain works, I like 3-digit numbers on the slides, so you don't have to stick with that, though. So we create the object on the heap with room for the state variables. And then I'm going to put a stack frame on the stack for the constructor call. The constructor is a method, so it gets its own stack frame. And we're going to add this hidden parameter. For every method call, including constructors that are part of a class, we're going to put this hidden parameter this inside the stack frame for that call. So I have the stack frame for the party character constructor. It's going to return to this hero variable that's where the value is going to go that this returns. And this hidden parameter this, which stores a reference to the calling object. In the case of constructors, a reference to the object that's being created. There are no actual explicit parameters here. We have an empty parameter list, so we only have the hidden parameter this. This as a parameter always does exist. It's always existed since our first day of Scala, since our first memory diagram. But as a rule of thumb for this course, at least, if we have an object, if this were object, we're not going to put this in there because we're just not concerned about a reference to that object. So for LO1 quiz, everything was in an object. We don't really care about putting, I don't even think we put the object declarations in there. It was just assumed that they're objects. We never put this in there. Technically, it's there. When you call pale blue dot closest city, technically that method call has a reference to the pale blue dot object in scope, as a hidden parameter. But we don't care when it's an object in this course, but it is still there. Once we're talking about classes, we're always going to put this in there when it's a method call that's defined in a class, and mainly because we're going to start using this. This gets really important. We're going to have this all over our classes. So we're going to put that explicitly on the stack so we know that we have a reference called this, and we want to know what it's a reference to. This one is a reference 282, which is a reference to this object that we're currently creating. Importantly, this does not store the variables. It doesn't store the object. It stores a reference, which I like to think of as a map. Your reference is your directions for memory. Heap space is this wide open, gigabytes of memory. That reference is your roadmap to say, okay, how do I find the object I'm looking for? Oh, it's at memory address 282. Okay, let me go there. And that's where I can find the space in heap for that specific object that I'm concerned about in this program. Once we're done with the parameters, we run all of the code outside of the methods. By convention, we usually put this code before all of the methods. It would be still valid code if you put it after, or if we had multiple methods defined. You could put it in between methods. All of that's valid Scala, but just for readability by convention, we all as developers agree, put all of that code before the first method so it's very clear what's happening. If you hide things at the bottom of the method, things get harder to read. You might not be looking there. Developers might not look there for your constructor code. So after the parameters, anything outside the methods gets executed, and any variables that are declared. So far, I've only shown variable declaration, and that might be true for all my examples. But any variables that are declared in this code become state variables of that object that's being created. So we created a player character object. We got no state variables from the constructor parameters, but we got 2 state variables from the code outside of all the methods. We got battles1 and XP, both initialized to 0. The constructor call ends, the stack frame returns, and what a constructor call returns, this entire thing here, this is an expression, thinking back to the early days of 1.15 when you first started talking about expressions and statements. This expression resolves with new and the constructor call. This expression resolves to a reference to the object that was created. And now, just like appending or prepending to a list or concatenating a string, if we want to see the change to memory that we just did, we have to store that reference somewhere. Here we're doing what we've done so far in the class. We're declaring a variable and storing that reference in a variable. So notice this reference is no longer on the stack. It's grayed out. That means on your quizzes you would cross them out. So that's gone. We need this reference somewhere, or else we wouldn't have access to this object that we just created. So we need to do something with that reference so we have access to that object. If we throw away the map, which would be if we just had new player party character with no assignment here, we would create the object, we'd get the reference, we would have create state variables, but then if we take that reference and just throw it away, if we don't store it anywhere, we no longer have any access to that object. And not a topic that we talk about in 1.16, but that object would be a candidate for garbage collection, which means it would be removed from heap space because we have no way of accessing it. In Scala, in the JVM, they're going to say, you can't even access that object. I'm going to delete it. And that's called garbage collection. It's a deep topic, but not a 1.16 one. But that's what would happen to that object. We're not doing that. We're going to store it in a variable, a reference to that object in a variable, so we can work with that object. We can still know where to find it in memory and not lose it, not lose track of it. Then we're going to call a method, hero.winBattle. So there's a bit going on here, quite a few moving pieces. So let's piece this apart one step at a time. First, I know there's a method call to win battle. There are two win battle methods here, but I know I'm going to get a frame on the stack for a win battle method call. And then I'm going to look at the calling object, hero, which doesn't really mean anything to me, but I'm going to look at my memory diagram and look up the value for hero. The value for hero is the reference 282, which is a reference to this object. And whenever I see the dot operator, I know that this means go from the reference to the object that's being referred to, or the object that's being referenced. So 282 dot, and then call the method while we're at this object. So when we call that, we know two things. One, this object is of type party character, so we're going to call this version of win battle, not the party win battle, but a party character. We call it through an object of type party character, so we call this win battle. And two, when in that stack frame, this is going to be a reference to the calling object. This is the object where we were when we called that method. So it's 282, which is going to be stored in this. Which, of course, we only have one object on the heap. We only had one choice for this one. But we're going to follow the reference of the calling object. Hero dot, this is the calling object. So 282 is stored in this. And then our parameter as usual. Mob XP. Mob XP is 20. XP is 20. This method call is going to update two state variables. This dot battles 1 plus equals 1. When we update a value, cross out the old value, write in the new one. This dot XP, this dot XP plus equals XP 20. Cross out the 0, write in a 20. Stack frame is removed from memory. It no longer exists. And this method returned unit. So I don't know if I mentioned this in lecture or not, so I want to make sure I do. When we have a method that returns unit, we don't draw any return arrow. It doesn't return anything. We're not calling this method for its return value. It doesn't change anything on the stack. There's no reason to draw that return arrow. What would we even draw for a method that returns unit? So we don't draw any return arrow. It doesn't return any value. We don't set the return value equal to anything. We don't do anything with that return because it returns unit. But that method call did change the state of memory for this program. It did change the program. This is what we call a method with side effects. This method call didn't return anything, but it did change the state of memory. And now after that method call, after that stack frame is erased from memory, we still see a change. Hero.battles1 and hero.xp, those state variables did change. So method calls, even if they don't return anything, can change the state of objects on the heap. Okay. Any questions up to this point? Because we're about to hit that beast of a line. Yes. Printing the state variables for that reference? Like if I wanted to print the heroes XP in battles 1? Right, that's the question. Oh. Yeah, that's a tougher question. So how do you print out what's in this? So you can access its state variables. Like I could print out this.battles1, this.xp to get the values, but that doesn't necessarily tell me which object I got those values from. It doesn't really tell me. If I have two objects on the heap that have the same values for their state variables and I'm just printing out the values, I can't tell which one it was. So that doesn't get us all the way there. So To tell that, I would run the debugger. So the debugger is going to have that party character at and then the reference for that party character. And then I would look at that in the debugger to be able to tell. At that point where you want to look at the references, you got to be at the debugger. You don't have to, but you should be at the debugger level instead of print statement debugging at that point. There are ways to do it. If I just print out, like in main, if I just printed hero, it would actually print party character at and then the reference number. So you could do that, in this case at least, and then print out this in win battle and see if those references are the same. But you won't always be able to do that. The short answer to that one is we're going to override toString methods later on, and then we won't be able to do that anymore. So we can't really rely on that. So my short answer is in the debugger. Okay. Any other questions on this? Because we're about to hit this line. So if there are any questions on everything we just went through, which was mostly stuff we did on Wednesday, but this is still new stuff. I mean, you've known it for less than 2 days, so I expect there to be questions still. Because if you have questions, the next line is going to be just overwhelming. Yes? Yes. Yeah, so it knows which win battle method to call. We have 2 win battle methods, which I purposely named them the same thing for this question. It knows which one to call by the reference that called it. So this win battle here was called through hero, which is a reference to a party character. So it knew to go to the party character class and call its win battle. When we get down here, we'll have a party calling win battle. We'll follow the reference. We'll do the same thing. We'll see that it's a party object, and then we'll go to the win battle for the party class. Difference between object and class? I forgot. So we use classes to create objects. Anything that's on the heap is an object. Absolutely everything on the heap is going to be an object. The only time we have classes is in our code, and we use classes as a template to create objects. So the class is like, hey, any object of type party character has this state and behavior. It's going to have 2 state variables, battles1 and XP. It's going to have a win battle method, and then these state variables can vary for each object of that type. But we'll never have there wouldn't be a class in the heap, except some advanced stuff that I shouldn't even mention, but you can, Scala's weird. In Scala, you can have an object of type class and store it in a variable in the heap, but it's not something we care about in 1.16. Somebody was typing, they must have changed their mind. All right, any other questions? All right, so let's get into the next line. So we have a call to a party constructor, which we've done before. Of course, the tricky thing here is going to be right here. But let me get the setup first. Where we see the keyword new, so we know we're going to create a new object. What follows is going to be a constructor call. We're calling new party, so there's going to be a call to the party constructor. So party constructor takes 2 references to party characters. So the 2 arguments that I see better be expressions that resolve 2 references to party characters. In a sense, has a lot of buzzwords in it. Classes and objects are not analogous to function definition, function calls. Yeah, actually kind of. I haven't thought of it like that. In fact, with the classes, the most important part of a class is I don't know if it's fair to say most important, but you're defining the constructor method, and you call that method to create objects. So you are creating objects using a class through a method call. So it is very similar to defining a function to call it. We're defining a method that you can call that returns references to objects and creates those objects. That's what the constructor is. So our constructor here takes two parameters. So we better give it two arguments here. First one, and this. So we're creating a new object on the heap. It's going to be of type party. I'm going to make up a number. I liked 334. The constructor call, the stack frame, is going to have that hidden parameter this, which we don't see in the code, and that's going to store a reference to the object which is being created. That we've all seen before. We have our first constructor parameter, character 1, is going to be hero, and I'm going to stop looking at my code at this point. This is one of the benefits of a memory diagram. I'm not going to look at my code. I'm going to look at my memory diagram. Hero stores 282, this reference. Okay, so character 1, I have kind of a hidden line as well. Val character 1 of type party character equals hero is the way we read parameters assigned to arguments. So character 1 equals this reference 282. That's all fine. That's not quite new either. But the next thing is a bit trickier. We have a constructor call as an argument for the second argument of this constructor call. So now we start the process over again. We see new and a constructor call. Oh, I missed my setup slide. So we're going to add the constructor call and create the object. This is the same thing we did when we created the first party character. We're going to create a party character on the heap with two state variables, battles1 and XP. They get both initialized to 0. The constructor call has a reference to the object that was created in the variable this. I chose 496 for this one. And then it's going to return that reference. And it's not returning something onto the main stack frame like we've seen before, but it's going to return it into the variable of the constructor call for the party constructor. So we're going to draw a return arrow right into your return arrows. Don't overthink the return arrows. Just draw them to wherever it's returning to. So I'm going to draw that into character 2, which is where it's going to go, and then return that reference into character 2. So we created a new party character, but we didn't store a reference to that character directly on the stack. I mean, we did, but we didn't. Well, let me just go one more slide before I make that point. So we have this reference in the constructor. We have our constructor parameters. Those automatically become state variables in Scala. So character 1, character 2, 282, 496. We have references to our two party characters as state variables in the party class. And yes, references can be stored in state variables, not just on the stack. We're going to run all the code outside of all the methods. It's just one line. It's going to declare a variable, so that becomes a state variable. Bless you. And battles1 equals 0. And then this stack frame is going to return a reference to that party that was created and store it in the party variable on the stack in the main method. So a few things here. One, this reference to character, what we would call character 2, and I'm going to try to stop calling them, like this isn't hero, character 2, character 1. One, we have hero and character 1 referring to the same character, so it doesn't always makes sense to use one of those names. Like, is this the hero or what is this? I'm going to call it the character at 282. Like, that's the actual name that will not change. Say I made hero a var, and I wanted to create a new character and have them be the hero now. Well, which one's the hero? If I used to call that one hero, I don't know, things get fuzzy there. If I just call this object 282, I know I'm always referring to the same object. That is never going to change. That reference can't change. That's where that object is in memory. So I know I'm not going to be referring to the wrong object when I'm talking. But this reference, 496, is no longer on the stack. It's nowhere on the stack. But we can still access that character. It still exists in memory, and we can access it, but we have to access it through the party reference. So if I say party dot character 2 dot, we can still get to this object, even though we didn't ever store a reference to it on the stack, at least not in the main stack frame. We stored it in this constructor stack frame, but that stack frame's not in memory anymore. That's gone. So we don't have a reference to that character on the stack, that 496 character, but we can go over to heap space where we did store that reference and access it that way. And one more thing, more of a side note, but I get the question of why don't we draw the main stack frame? We're doing these memory diagrams. This is a good example of why not. Where would you draw it? So we would draw it here. You know, that's fine until we have party declared after a few stack frames that were crossed out. Now, do we draw another separate box around party and write main next to both of them? It gets awkward, it gets cluttered, it gets messy. So we just say anything not explicitly inside of a solid box stack frame is implied to be in the main stack frame. Keeps things a lot cleaner. If we were going to explicitly draw the main stack frame, I honestly don't even know how we would end up doing that. Next to each variable name, maybe write main next to it. Main. I think that'd be a pain. So we just don't draw anything. Anything outside any stack frames, it's implied to be in the main method, main stack frame. And for other stack frames, we'll make enough room for those variables that get declared outside of the stack frame. I guess we could do the same thing with main. That's what we would have to do. We're not gonna, though. All right, any questions here? Actually past that beast of a line. Okay, now party.win battle. This is a little more unassuming, but this one gets a little bit, a lot of moving pieces. It's not, I would argue it's not overly complex, but there's a lot of stuff to follow. And if you miss one step, you can get really lost. So I want to make sure nobody gets lost. So please ask questions if you got them. But party.win battle, kind of the same thing that happened over here. The party, our two characters now took out a boss, and they need to get the XP and get those stats boosted. So we're going to add a stack frame for win battle. We're going to look at the calling object, party.win battle. We're at this object when we call win battle. It's of type party, so we're going to call this win battle, which is defined in the party class. So we're inside this win battle. We were at this object when it was called, so the calling object is 334. So this is 334, the calling object, and then XP, boss XP, 100, that we've done plenty of times. We're going to increment battles 1. So this, always follow the reference with the arrows. It makes it nice and easy to see where to follow. This dot, the dot operator always says, your reference, I want the object that you refer to. This dot, battles 1, increment by 1. Cool. We've seen that too. We've seen that in the first call up here. But the next line, here we go. This dot character 1 dot win battle of XP. So again, we're going to follow the references. And it's important that every time you see the dot operator, you are following a reference. Remember, you're following a reference when you see dot operators. So we have this dot. We're in this stack frame at the time. This dot, character 1, dot, we get all the way to this character, and then call win battle. So when win battle is called, we're going to note where we are in heap space, what object we're currently sitting at. It's of type party character, so we're going to call this win battle, and it's at reference 282, so this is 282. And XP is 100, that really didn't get more complex at all. XP in this stack frame was 100, we just forwarded that to the next one. Now we're going to execute this code in this stack frame. So we're going to follow the reference, battles 1 plus equals 1, this dot XP plus equals XP, cross out the 20, increment it by 100, 120. So we update the state variables of that object 282. That stack frame returns, and we're going to do the same thing with character 2. This dot character 2 dot win battle. It's of type party character 496. 496 and call this method increment the values. 496 won 1 battle and gained 100 XP. For what it's worth, we're not splitting XP. Every party member gets full XP in whatever game we would be simulating here. Okay, any questions here? This is the peak complexity of this example. If you got everything from here, you're doing freaking solid. If not, I want your questions. Give me your questions. If no questions, I'll just talk about random stuff. So the lore, this came up in the other lecture, and I think it clarified some things. So the lore of this, if you're following that, we have a character who's out adventuring on their own. They kill a mob, they gain 20 XP, and that's what's happening right here. They go to a town, they meet another character, and they create a party with that second character, and together they go fight a boss and gain that XP. So the initial character, this 282, beat the mob and the boss and won 2 battles as a party after they formed the group, because that first battle happened before they formed a group. After they formed a group, they only won 1 battle. So even though this party character won 2 battles and is part of this party, the party, after they formed the party, has only won 1 battle. So they only get 1 win. This character, they weren't a part of this. They weren't a part of this battle at all. They haven't formed a party yet, and this character didn't even exist. According to the code, it was created right here. So this character doesn't get that 20 XP from that mob win. Exactly. That was answered in chat, but just to make sure. Party, when we did party.win battle, we did this dot character 1, this dot character 1 dot win battle. We're at this character. So party.character 1 stores the reference 282, and so does the variable hero. We have 2 different ways of accessing the same party character, this 282 party character. So it gets confusing if you call it character 1 or hero or the first character of the party. Things can get mixed up if you start referring to it as that. But if I say 282, I know I'm always referring to this character, this object that exists in heap space at a specific location, And I happen to have two different references to this character. So when I say party.character1.win a battle, the variable hero refers to the same object, has a reference to the same object, so the hero variable can also see that that battle was won and that that XP was gained. It happened through the party, but if I follow my references, technically from here, if I follow my references, I'm modifying the same object in the heap. And this is the important point, the important lesson with Wednesday's and today's lectures. We're following the references, and we can modify the heap, and we have to keep track of our references to make sure we know which object is being modified. If two different variables store a reference to the same object, they both see changes made to that object. That's the really important key point here. So it happened to be party.character1 won that battle, but hero stores a reference to the same exact object. So both variables see the change because they both refer to the same object. Very, very important point, and one that's easy to lose track of when you're first learning references and how these things work. It's very easy to lose track of, which is why we did a whole week of memory diagrams on it. Oh. All right, any other questions? All right. Stack frame ends. Stack frame ends. Oh, come on. And we're going to print things to the screen. Hero. And at this point, I wouldn't refer to the code at all when I'm doing these memory diagrams. Refer to the values in your diagram, which is exactly what the computer is going to do. Don't overthink things. Don't think about it too much. Just follow the values in your diagram, because that's exactly what the computer does. It's just looking up its values in memory when it's running your code and just blindly going by whatever's there in memory. So what the computer's going to do, print hero.xp. Let's see, do I have a variable named hero? I do. Dot, okay, that must be a reference. I'm going to go to follow those instructions and find the object. Dot .xp, that's 120. Print it to the screen. Party.character2.xp, okay, do I have a variable named party? Dot character2 dot xp 100. Print it to the screen. I'm not going to go through my code and trace through everything that happened because, well, we already did that. And when your code is being ran, that's exactly what the computer's doing. It's going line by line, running your code and updating memory, and then only referring to memory, not your previous lines of code, to figure out what to do on each line. If I had another print statement here, which I probably should just add to this example, party.character1.xp, it's also going to be the same 120, the same variable as hero.xp. Any other questions on that? Back this up. Okay, I want to talk a little bit about the project. We have classes now, and this is something we haven't tested before. We've tested object. I'm doing a hard gear shift, by the way. We've tested objects, pale blue dot, closest city, whatever it returns, check if that's what we want. We have to do things a little bit different when we're testing classes, so I just want to get this out there of how we're going to test classes. When you clone the repo, you're going to have these 3 lines of testing code commented out. I'm going to comment them in and immediately get an error, which is why they were commented out. Actually, I'm not, because I have my changes from last lecture. I'm going to get an error because when you first get the code, item is going to look like this. You're calling a constructor with 2 arguments, but that constructor has 0 parameters. So I'll add that right back in. You don't have to watch me type those ones. I need a constructor parameter for the description of the item and the base price of an item. And I'm going to choose whatever names I want for those. Then when I go to my testing, I get rid of that error, and I'm creating an item with the description test item and a price of $100. So when I'm testing a class, the very first thing I have to do is create an object of that type. I need an object of the type of my class, so I'm going to call the constructor, create an item of that type, or an object of that type, of type item in this case, and then test the object. We don't really have the methods to be able to test a class directly, create objects using the class, and then test the objects, test the behavior of those objects. So once I have this item, I can start asserting things. And very importantly, I'm going to check the description. Very importantly, I'm going to use the methods defined in the homework doc. So the homework doc, the handout, that's going to define, that's like your spec sheet. A customer gave you a spec sheet, said, build me something that does all this stuff. When you're testing, only test what's on the spec sheet. Only test those things. You can do more tests, but don't submit those to my analogy's falling apart here, but don't submit those to Autolab. Only the methods defined in the document and any variables defined in the document are valid to be used in your testing. And the reason for that is when you call, like say you want to change this to the description, which, oh yeah, I can't even access. But if I had that as the description, I can't access it because I didn't use val or var, so it's private. If I said the description testing the variable, well, that variable is something I named when I wrote the item constructor. Like I chose what I want for it. The homework doc purposefully doesn't name your constructor parameters. You get to choose whatever name you want for it. And with all likelihood, you chose a different name than I did for my correct and incorrect solutions. So if you're testing that variable, that's fine when you run your test locally, but when you submit to Autolab and you're calling that variable on my code in Autolab, I have different variable names, and you're going to get errors in Autolab. So when you see those slanted faces, the concerned faces in Autolab, and it says error while testing your tests, running your tests on a correct solution, the very first thing you should check is, did you access any variables that you chose the name of in your tests? The answer is usually yes, and then you fix it. So make sure you're calling the method description. That method is defined in the homework doc. That means you're going to have a method name description that has no arguments and no parameters and returns a string. And I'm going to have the same thing. I don't feel like saying that sentence again. But I'll have the same thing in all my code, correct and incorrect solutions in Autolab. So I'm going to assert things. I'm going to assert that the price is $100. I'm not going to type it out because I don't feel like setting up all my epsilon stuff. Then I'm also going to call the other behavior, test item dot set base price. Maybe I'll cut this in half to 50. And then I'm going to assert that that price did change by calling the price method. Assert test item dot price, not accessing my price variable, but I'm going to call the price method and make sure that returns the correct price for this item. And then that's where I would use my absolute value, epsilon, all that good stuff, which I just don't want to rate right now. When you get to the self-checkout, and if you didn't read the homework doc and this doesn't make sense, I encourage you to read the doc and see what's going on. There is a lot of text. It's not overly complicated, but there are a lot of pieces to it. So when you get to the self-checkout, you're going to add an item. This is adding an item to the cart with a barcode of 1, 2, 3. And I'm going to simulate button presses by calling the appropriate numbers, appropriate methods. I'm going to simulate pressing 1. Oh, come on. 1, 2, 3. Oh, I'm trying. Cart equals access the cart. And then importantly, I don't have time to type the whole thing up, but importantly, check the cart. Make sure the appropriate number of items exist in the cart first, and then check if each item is what you expect. Make sure you're checking the number of items first. I would assert, well, I can do this part. Cart dot length equals 1. Make sure you're doing that first. Some of my incorrect solutions won't return the appropriate number of items in the cart. It might return an empty cart. If you're trying to access the first element of an empty cart, you get errors in your tests, things break, and it's no fun. So make sure you're checking the size of your cart first. Those are the hints I wanted to make sure I got out there. Yeah, once the program ends, any objects in the heap get destroyed. Any memory that was given to your program, it's all destroyed, stack A and heap. Oh, and have a great weekend. I'll see you on Monday.